Hello, everybody. We'll just give it a few more seconds for some people to join, and then we'll get started with this workshop. All right. Welcome, everyone, to this Ocean Best Practices workshop on GHRSST Data Specifications, best practices for SST data producers. So I will be the moderator for today, and my name is Erika Hayashi, and I'm working at the Danish Meteorological Institute, and I am part of the GHRSST project office, but more on that to come for those who aren't familiar with the GHRSST project office or GHRSST itself. But just to start off with a brief overview of what we have on the agenda today. So we'll start off with an introduction and welcome to GHRSST. We will also then go into an introduction to the GHRSST Data Specifications, the GDS. And then following that, we are going to go into different user perspectives of the GDS from across different countries as well. And then we'll end the workshop with questions. So if you have any questions, you can use the function within Zoom here or in the chat. All right, so just to start off, welcome. I already mentioned the GHRSST project office, but just to give you a little information about what it is. So the GHRSST project office is hosted by the Danish Meteorological Institute in Denmark. And we have the project coordinator, which is myself. We have also a scientist, a project office scientist, which is Pia Inglyst. And then we also have a team behind the GHRSST project office, including colleagues at DMI, Jakob Høyer, Joanna Caragalli, and Chiara Berzatti. And the GHRSST project office is funded by the European Union Copernicus program via EUMETSAT. But what does the GHRSST project office even do? So the GHRSST project office supports the science team and science team chair of GHRSST. And I will also get more into that later on. And we also support the different task teams in GHRSST. We maintain documentation, websites, and social media. And we also have a key activity that includes organizing capacity and outreach activities for GHRSST, such as today's workshop. And then just speaking a little bit more about GHRSST, we also have training and guidelines that we have accessible on our website. So this is where we hold in-person or online trainings. So we also delivered, for example, an online training, or sorry, in-person training for SST users, sea surface temperature users in Ahmedabad, India last year. We also have how-to guides, which are videos and manuals for SST data producers and users on our website. And you can visit the website at grist.org here. And just to give you a background about what GHRSST is. So GHRSST is an acronym, and it stands for the Group for High Resolution Sea Surface Temperature, and it's an open international science group. And the group sets out to provide operational users and the science community with SST, sea surface temperature, measured by the satellite constellation. And GHRSST provides a framework for SST knowledge and data sharing, best practices for data processing, assessing uncertainties in satellite SSTs, and is a forum for scientific dialogue, including how to best provide SSTs for climate studies, bringing SST to the operational users and scientific researchers. And just to sort of give an overview of about how we work within the group. So GHRSST is led by an elected international experts, also known as the GHRSST International Science Team. So that's in the middle purple box there. And the science team coordinates the data production and related research and continuous efforts to refine the GHRSST data management structures, ensure a functional system that conform to international directives and results in easy access and guidance for users. The science team also establishes technical advisory groups. So this is the 4 boxes just under the science team here, and they address long-term issues of cooperation and coordination. We also have the GHRSST Advisory Council, which advises the science team on its strategy. And then, yeah, we also have the project office, as I mentioned here, and that's, like I said, located at DMI, the Danish Meteorological Institute, and we support the day-to-day coordination and working of the science team, and also the technical advisory groups here. And then who is involved in GHRSST? So there are many organizations sponsoring and involved in GHRSST activities. So here's just a quick snapshot of all the different agencies involved. And then sort of how can you stay up to date with us and know what we're up to? So you can follow us on Twitter or X, LinkedIn. We have a YouTube channel where we post all of our GHRSST talks, where we have different SST users and researchers presenting their ideas, their research results, etc. And we also have a repository on Zenodo where you can find any documentation related to GHRSST. But more about today. So just an overview of today's objective. So today we are aiming to introduce and promote the recommended GHRSST data specifications, specifically targeted for sea surface temperature data producers and also users. We hope to introduce you to the GDS, the GHRSST data specifications, so you gain an understanding of what it is and its importance and also where to find it. We also hope to highlight why a data producer should adopt the GDS. We also would like to share some experiences from users who are using the GDS to demonstrate any benefits, practical applications, but as well as challenges. And we also would like to have a forum for knowledge sharing, so encouraging SST producers to adopt GDS and improve data production accessibility. And so just an overview of some GHRSST data producers, and also just to introduce who we will be having later on today as our speakers. Here is a list over all of the GHRSST data producers. And today we will be highlighting 3 GHRSST data producers, so including from the Australian Bureau of Meteorology, the Copernicus Marine Environment Monitoring Service, and the Danish Meteorological Institute. And just an overview of our speakers for today. We will have Pia Inglus from the GHRSST Project Office and also at the Danish Meteorological Institute, based in Denmark. We also have Pallavi Gavkar from the Bureau of Meteorology presenting a perspective from Australia. We also have Christina Tronconi from CNR ISMAR, Goss, presenting her perspective with the Copernicus Marine SST products. We also will have Joanna Karagali, who is part of the Danish Meteorological Institute, who will be presenting that perspective. And then last but not least, we have a last-minute presentation from Neeraj Agarwal from the Space Applications Center, presenting the preliminary first steps of implementing the GDS from the Indian Space Research Organization. And before I hand the floor over to our first speaker, Pia, I would like to sort of understand just where our starting point is to understand who is in the room, what we already know about the GDS, about the GHRSST data specifications. So if everyone could either scan this code, and I will also put the link into the chat here. So then give me a second. And then I will also share my screen. Everyone. All right. Okay. So just so we can try to understand of who is actually in the room with us, I can see some familiar names in the participant list. But if we could get an overview, so who we are we SST data producers? Are we users? Are we research scientists or SST researchers or scientists, students or other? Let's try. Perfect. So it seems that we have an equal match of producers and SST scientists. Nope, a little bit more. Awesome. And then I'm going to move over to the next question. Do you use the GDS? Yes, I use it to produce GRIS formatted SST products. Yes, I use it to understand. No, but I would like to. Or no, I don't use it at all. No, but I want to get started with producing, knowing about GRIS formatted products. So you're in the right workshop for today. And then we have our last one. So how much do you know about the GRIS data specifications? I know nothing, I know a little, I know some things, I know quite a bit, or I know a lot about it. Okay, so it seems like the majority know nothing about it or know a little bit about it. So, and there's also quite a few who know quite a bit, but I think it's great that we have some people who hopefully will get to learn a little bit more about the GDS today. So I will just stop sharing my screen on this one, and I will pull up our next presenter, who will be Pia Inglust, who is part of the team here at the GRIS project office and also my colleague at DMI. So give me 1 second, Pia. Right.
Great. Hi, everyone. Yeah, thanks for listening and thanks for the introduction, Erica. So now I'll present a short introduction to the GHRSST Data Specification, the so-called GDS. But I should also say that Jean-Francois Piolle from IFREMER, he is really the man behind the GDS. So next slide, please. So for those of you who are not familiar with the GHRSST, this is a document that describes the GHRSST recommended format and content of SST data products. It covers all the data levels from level 2, level 3, level 4, and also multi-product ensembles. And the document contains information on the variables that should be put into the different products, and the conventions for flags, quality information, ancillary information that should be added to the product, global attributes, uncertainties, and so on. The first version of the GHRSST came out in 2004, and the latest version is version 2.1, which was published in 2021. The GHRSST is available from the GHRSST website and also from the link included in the slide here. Next slide, please. So who is the GHRSST actually for? It's for producers who wish to produce any level of GHRSST formatted data products and needs guidance on best practices and control code tables for identifying sources of SST and ancillary data that are used within the GHRSST data files. The GHRSST is also produced for users who wish to fully understand the GHRSST products, conventions, and the file contents and definitions for SST and other useful information in this regards. Next slide, please. So yeah, why should we use the GHRSST format? Well, as it is now, it provides a common format for SST products adopted by about 20 agencies producing a total of more than 150 datasets, with more datasets being added each year. And the main benefit of having this common format is, of course, to provide the interoperability between all the GHRSST formatted datasets and services. And the GHRSST format and specifications are based on the heritage of SST experts and more than 20 years of discussions and agreements in this community. And for producers, it also saves a lot of time because there's no need to reinvent the wheel and create a new appropriate format each time a new dataset has been produced. The GHRSST provides a clear and unique vocabulary and associated definitions. It provides a built-in traceability metadata, and the SST is shipped together with all the relevant set of ancillary variables that allow interpretation of the SST data. And for the users, it's also a lot less of a hassle because all the data sets are provided in the same format. So in particular for applications that need to merge multiple data streams like model assimilation and so on, it's really a game changer in this regards. So in summary, this saves a lot of time for both the producers and users. Yes, next slide, please. Currently, many of the GHRSST formatted products are available at a central GHRSST catalog. It is a fairly populated catalog which can be used for dataset discovery, and it's available from the link in the slide here. And you can see a screen dump of the catalog where you can see examples of the first 4 products that pop up when you enter the GHRSST catalog. And by using the searching criteria on the left, you can easily find the products that you need for your applications, either by searching on the geographical area, satellite sensor, data level, latency, or any of the other options that are available here. And you might also be able to see that there are currently 68 products in the catalog, and there are still ongoing contributions and updates. So we highly encourage you to put your GHRSST formatted products in the catalog. And in the slide here, there's also included a guide or a link to a guide and demo on how this should be done. And also a benefit of this is that all the new products that are being developed, including those from ESA and EUMETSAT, they will also be provided in the GHRSST format. Next slide, please. So what are the next steps? The GHRSST is continuously being developed and evolved to meet the requirements and requests from both producers and users. And this development, of course, happens in close collaboration with the GHRSST science teams and the producers and users. And currently, we are trying to address the feedback that we have received since 2021, with the main requests and concerns being listed here. And these are, oops, I think, at least I can't see your slides anymore, Erika. Great. Yes, thank you. One of the things is that right now the GHRSST is written in Microsoft Word, and it is very big and hardly manageable for both producers and users. And the history of versions and changes are not very transparent. And a shared open source environment such as GitHub has been suggested. Moreover, there has been a request for the addition of sea ice surface temperatures, IST, specifications in the GHRSST. And also there has been several requests for a new up-to-date file format checker. To meet the first 3 of these, the GHRSST is currently being transformed from Microsoft Word into a Jupyter book, which is shared in GitHub. Next slide, please. And here you can see a screen dump of how this is gonna look. And compared to the Word version, the Jupyter book is much more easier to navigate in. And many of the cleaning and formatting issues are avoided. And it's, for example, possible to include NC dump directly in the Jupyter book. And also the sharing in GitHub makes it much more easy to track changes and versions. And it's also possible to assign sections or update to editors and to users to be able to suggest changes. If you want to see more of how it's working and going to look, you can click on the link in this slide here. And currently we are planning 2 releases. One release later this year, GHRSST version 2.2, and that will include minor changes and fixing of known errors and issues. It will be moved from the Word format to the Jupyter book, but other than that, it will remain compliant with the previous versions of the GHRSST. And for June next year, when we will have the next GHRSST meeting in Copenhagen, we are aiming for the first public release of the GHRSST version 3. And this version will include more major changes, such as the IST integration. Next slide, please. So as a producer, it can be very difficult to check that you're actually meeting the GHRSST requirements. And therefore, there's been several requests for file format checker. And this is currently under development, funded by the Copernicus through EUMETSAT. It will be a light, portable, easy installable pip Python checker that is going to work for both level 2, level 3, and level 4 format verifications. It will be available on the GHRSST GitHub. And for the next slide, there are 2 examples of the output that you get when you run 2 files through this format checker. And you can see that it goes through all the variables and global attributes and checks whether they are meeting the conventions and specifications or not. And hopefully this will be of great use for those who would like to put their data into the GHRSST format. Next slide, please. Yes, and if you want to do that but haven't started, I think the first step would really be to take the GHRSST and look at the examples and code provided. And then please reach out to us at the GHRSST project office. We are happy to help you in this process. And if you have any other questions or concerns in regards to the GHRSST. That's all from me. Thank you.
Thanks, Pia. All right. So if anyone has any questions for Pia, you can put them into the chat and we can round these up at the end of the of our session here. But now we're going to dive into sort of the perspectives of people who are using the GDS. So now that you hopefully have a good background about what the GDS is, why SST users should adopt it, and where to find it, we are going to go over to Australia, where we have Pallavi Gavkar giving her perspective from the Bureau of Meteorology. Go ahead, Pallavi.
Yeah. Can you see my screen okay?
Yes, it's in presentation. I can see your notes. So I think you have...
Okay. Is it good now?
Yes.
Yeah, good. Okay. So, hi everyone. I am Pallavi Govekar from the Satellite Science team in the research program of the Bureau of Meteorology. I would like to acknowledge my co-authors here, Helen, Chris, and Kat, who are working on these products along with me. And Integrated Marine Observation System, IMOS, they are funding all this work for years, and I would like to acknowledge them here. So all GHRSST products have a standard format, as Pia explained, and include uncertainty estimates for each SST measurements on a pixel level. They are served free of charge through the GHRSST Regional Global Task Sharing Framework. Currently, there are hundreds of SST products provided in level 2, 3, and 4 formats as specified in the GDS documents. So the Bureau started using the GDS version 1.7 for our level 4 products in 2006. Then from 2010, we used the GDS 2.0 format specification for our all level 2 and level 3 products. And for level 4, we started that producing them in GDS 2 from 2019. We have adopted the new GDS 2.1 specification for our new reprocessed Himawari 8 and 9 SST products that we developed recently. So, as a part of IMOS, the Bureau of Meteorology provides a range of high resolution level 2, level 3, uh, um, and level 4 grease products over Australian, Antarctic, and global domains. Uh, these are formed with data from AVHRR, VIIS, and Himawari infrared sensors and MSAR2 microwave sensor. We provide these products at two depths, skin SST at around 10 micron depth and foundation SST equivalent to SST measured at several meters depth, or SST measured at night or in well mixed conditions. Um, so here is a big list. I don't expect you to read it, but we provide 39 different real-time and reprocessed grid products available via the National Computing Infrastructure Thread Server, that is NCI in Australia, uh, with a subset available from AODN. So AODN is Australian Ocean Data Network, and through their portal they serve our SST products along with other in situ ocean observations. To suit various applications, the products have different spatial and temporal resolutions, a local time of day, so they are day, night, or day and night. Processing levels different, so L2, L3, or L4, and depth, skin, or foundation. Uh, so all our products follow a grease specification with useful information at the pixel level. So here we see examples of variables in one of our level 3 S files, supercollated L3S, from different satellites. So we provide like nighttime composite skin SST from multiple satellite sensors, then quality level based on proximity to cloud only, then bias with respect to drifting voids SSTs and corrected to skin. It varies smoothly over space with latitude and longitude. Standard deviation based on matchups with drifting voids calculated daily, but using a model that uses the past year of matchups weighted to most recent observation. L2P flags contain information on type of sensor, land, ice, aerosol, deviation from analysis, and producer specified flags like low wind, high wind, etc. DT analysis is the deviation from the background SST used. SES count is number of observations used to calculate bias and standard deviation, and along with the other things like satellite zenith angle, wind speed, sea ice fraction, and more. So, yeah, lots of information in the file. So one thing is the quality level that is given with these products. Uh, in the case of level 2P products derived from infrared radiometers data, the quality level of the data is based on the estimate of the degree of cloudiness or other form of atmospheric interferences such as from dust or aerosols, and data producer decide their own quality method. So, but the standard format is for QL is equal to 0 is no data. QL1 is the bad, so it is affected with cloud, rain, or close to land outside valid range. Quality 2 is worst quality. Quality level 3 is the low quality SST data but still useful for some applications such as visualization. Quality 4 is acceptable quality for applications such as ocean models or SST analysis ingestion. And quality 5 is the best quality and it is recommended for satellite SST validation. Um, The two other important variables in GDS are the sensor specific error statistics bias and standard deviation for each SST pixel. We use our own empirical SES bias model based on matchups between the satellite SST and VOI SST data. This uses matchups from a rolling 1 month window adjusted every 5 days and a 6 dimensional model based on time of day, satellite zenith angle, quality level, longitude, latitude, and age. A geostationary satellite specific SES bias model we have developed recently for Himawari 8 and 9. So when we use others' product as a data user, how this GDS format is helping us. So at the Bureau, with limited resources, we cannot process each satellite from scratch in-house. So, but our users need gap-free high-resolution L3S products for their different applications. So the way around what we do is we use other institutes level 2 or level 3 products and composite them together. So we use IMOS AVHRR L3U and OSISA PRAC AVHRR L2P and Novastar ASPO VS L3U GRIS products to construct our multi-sensor L3S products. Uh, because these products are GDS compliant, we can easily weigh up their quality. To merge data from these different satellites and producers, different L3U products are modified such that the modified quality level is derived from the original quality level given by the data producer and SES bias and standard deviation. This way we can track degradation of quality when sensor is not performing well. And more details can be found in this Goveka et al. 22 paper if you are interested. Um, and then how these GDS format products are helping us as a data producer. So user uptake and beta science. So bureau applications like marine heat wave monitoring tools that are shown here on left side are our NWP models need quality assured operational satellite SST products. So the consistent grids format with uncertainties, quality flags, and metadata encourages broader use uptake and better science. Also, producing products in GRIS format means they are distributed internationally, and this has enormous benefits, as I will show in next slides. So we provide 39 real-time and reprocessed GRIS products. They are available with NCI thread servers with a subset available from the AODM. So to suit various applications, the products have different spatial and temporal resolutions. AODN now is developing cloud-based tools that would let users to retrieve time series of SST for more than 30 years at any point in the oscillation domain on which we provide our products in less than 4 seconds. So it is a big benefit the people who don't want to use netcda file themselves, they just can get the time series from these tools from AODM. Several of the Bureau's GDS format L3C, L3S, and L4 products are now in the new GHRSST catalog. As you can see here, this exposes them to international users. RAMSA GAMSA, our level 4 products, are provided in near real time on the PODAC portal. Having the GAMSA SST analysis in GDS format and available in real time through PODAC allows it to be used with 10 other SST analyses to form the GHRSST multi-product ensemble GIMP, and the METOP is to provide useful comparison with GIMP and independent ArgoSST. Other agencies validate our L4 SST products, so that is a big benefit for us. The SST quality monitor web tool provided by Nova Star. It allows us to validate the GAMSA global SST analysis in near real time by comparing with other GHRSST L4 products, GIMP and ArgoSST, and identify issues if there are any. Shown here are GAMSA minus other L4 analysis for 1 day. So apart from special coverage and accuracy of SST products, it is useful to be able to assess an L3S or L4 products resolution of small scale ocean features. For quick looks of some L3S and L4 products in Nova Star's ARMS web tool. Here, our IMOS multi-sensor L3S nighttime skin SSTs are plotted up the northwest coast of Australia for 1 day and compared with Nova Star nighttime PM VSL3S VSL3S subskin product. Then there is a Nova Level 4 Geopolar Blend SST product. Bureau's RAMSA, Moore level 4, and Ostia level 4. So the comparison is very easy to see with these tools. Both the Bureau's and Nova's GHRSST format L3S products are on the same 2 kilometer grid, which facilitates comparisons. Then our IMOS products are displayed with IMOS ocean current. So shown here are the SST percentiles calculated from the IMOS 6-day nighttime multi-sensor L3S SST composites and stars climatology. Overlaid on this map are, if you can see my screen there, my cursor there. Overlaid on this map are also the percentiles calculated from IMOS ship SST data from container vessel OSIL Houston. So why do people in Australia use GHRSST format products? The IMOS GHRSST products are very easily and freely accessible via the AODN and NCI thread server. The common GHRSST format means that it is much faster and easier to ingest the products into ocean models and analysis. The Bureau ingests only GHRSST L2P and L3U SSTs into SST analysis and ocean models, and we subtract SES bias from each SST value before using it. Users of IMOS GHRSST products like the common 0.02 degree grid projection, and most importantly, quick look maps are available from AODN and the IMOS Ocean Current portal. So we see big benefits by adopting GDS, but we also think some improvements can be made. And this is with our experience of using GDS 2.0 and 2.1. So as already Pia explained, the new versions are coming and some of the things might be already answered with those new versions. So producing GDS compliant products can be time consuming, especially in the initial stages due to extensive information that needs to be read, understand and implement with these GDS documentations. The number of mandatory variables varies for each product level. So therefore the Python file checker should differentiate between these levels before checking file formats. One thing that is developed for one type of product cannot be used for other products. So that differentiation is needed. Currently, each data producer uses a different SES method to calculate uncertainty to their observations. Standardizing this process would allow for better comparison of products from different producers. And other thing we think is for the super correlated L3S products, the source of SST variable is mandatory and must describe the source of SST pixel by pixel if more than one SST source is used. This approach works with decision trees or selection hierarchy approach, but not with the averaging approach. Satellite sensors do not perform consistently throughout their lifetime, making it challenging to maintain a hierarchy approach in operational systems. So, some support with the average approach for making L3S products should be supported. So here are some links to useful information and tools for users of GRIS products. Of particular note is the introduction to users on the set of GRIS products published online by GRIS Project Office. Also, there are some links to IMOS GRIS products if you are interested to have a look. To summarize, the Bureau of Meteorology, through funding from IMOS, has produced 31 years of 39 high-resolution GRIS-compliant products useful for monitoring marine heat waves, coastal upwelling, coral heat stress, and climate trends over Australasian waters. These Australian quality-assured satellite SST products would not have been possible without the amazingly generous help from the GRIS science team. And here, left-hand side is our team at the Bureau working with IMOS SST. Thank you.
Thank you, Pallavi.
Yeah, so I will stop sharing.
Perfect.
Yeah.
Are there any questions just after Pallavi's talk? Otherwise, you can raise your hand now, or you write your question in the Q&A function at the bottom of your screen, and we can also take that after. Perfect. So our next presenter will also be giving another perspective. So we have Cristina Tronconi from the Italian Research Council Institute of Marine Research, from the Satellite Oceanography Group, who will be giving a perspective on the Copernicus Marine SST products. So I will mute myself and I will hand the floor over to you, Cristina.
Okay, I will share my screen. Can you see it?
Not yet.
Not yet.
Great. And then I can see it now. And if you put it into presenter mode.
Yeah. Okay. Wait. Okay. Is it working?
Looks good. Yes.
Okay. So, good morning to everybody, or good afternoon, wherever you are. I'm Cristina Tronconi. I work for CNR, the Institute of ISMAR, Institute of Marine, and work in Rome. This is the list of all my colleagues that helped me in my work. And I will speak about the Copernicus Marine SST products and the use case of GHRSST GDS form. So, a quick overview of this summary of this presentation. I will speak quickly about the Copernicus Marine Services, about the SST TAC catalog inside it, and in specific, the CNR ISMAR GOS production. Okay. Then I will speak about Copernicus data format and convention as, of course, the use case of GHRSST GDS in SST TAC. And then what's the future, the cloud computing challenges, in my opinion. Okay. So Copernicus Marine Services providing free and open marine data and services to enable marine policies implementation, support blue growth and scientific innovation. The structure of these services is this one. We have 7 monitoring and forecasting center, MFCs, that provide and deliver model data, and 8 thematic assembly center, TAC, that primarily provide and create and delivered satellite and in situ observation. This is a list of the thematic assembly center and of the monitoring and forecasting center. You can see quickly with calm reading my presentation. So the SST TAC is in charge of the near real-time NRT and multi-year SST products for the global ocean and the European regional seas. These, you can find the links directly to the Copernicus SST TAC catalog, where you can reach, from which you can reach these pages, and using the filter or free text searches, you can find L3, L2, L3, and L4 level data you're interested in. You can set the area, the variables, and whatever. From here, I want to underline which product SST product we deliver. The catalog, the SST TAC catalog delivered near real-time L4 and L3S data for operational application, and multi-year or reprocessed L4 and L3S data for climate application. This is a screenshot of some images of the L4 data for each area, the global and the other one, Black Sea, Baltic, Mediterranean, and Atlantic. So each SST product provides a daily mean map of foundation SST at a given spatial resolution, and recently a daily hourly mean maps of skin and subskin SST are also available. Detailed information of each product, there are many products inside the catalog, are reported in the PUM, Product User Manual, and in the QID, Quality Information Documents. Regional products obviously are suited for specific regional sea. The 99% of SST TAC products are now compliant to GHRSST specification, at least the oldest one, GDS 2.05, but quite all of that GDS 2.1. Now I want to speak to you about, just a few minutes, about the product I'm much involved in, the CMEMS, the CNR ISMAR GOS products. We produced night SST products, diurnal, and reprocess. Obviously, I will not read all of them. It takes too much time. I only want to underline that perhaps for the first one, I give you in the presentation the quick link to get the information throughout the Copernicus catalog. From the DOI address, the DOI number, you can reach quite quickly the pages into the Copernicus catalog. And especially I want to point it out the link, the easy link to the user manual and the quality information document. So for each of our products, I put in the presentation this information about the PUM and the quid. Okay, the processes change for night SST, for instance, is inside the PUM. And in the PUM, you can find how we produce all our data and the quality and all the information. Regarding the processing change, as you can see, is make in a modular way, and each modular is has a sequence. And so we start for each processing change from the collection of the input data, that could be L2P for night or L3C data. Then we extract the area we are involved, we are interested in, Mediterranean on Black Sea. We put together all the information and collate all the information in an L3S data at two different spatial resolution, ultra high resolution and ultra high resolution. Then using the optimal interpolation, we create the L4 data. Then we transform the binary data in the delivery format, the format we use to deliver the data, and we deliver through the Copernicus marine data. What we put inside the L3S data for each variables, the scheme select the best measure available for each pixel and correct the bias among the images by adjusting them to a reference SST. This reference SST is defined through a predetermined sensor validation statistics. The L4 data is a two-step algorithm that allows to interpolate SS data at high and ultra resolution, apply the technique of optimal interpolation. The relevant variable in L4 data are prevalently analysis SST, that is the optimal interpolated L4 data, and analysis error that came directly from the estimated error of the optimal interpolation method. Okay, so I go quickly to the main problem, the main issue or the main topic. What is the format of the Copernicus marine products? NESCDF, of course. Why? Well, the NESCDF is complied to climate, is easy complied to Climate and Forest Convention, but also we built our data following the Copernicus Marine Convention. But this is not enough. What we want, adopting the NESCDF format, we want to make a step forward the open science. What does it mean? Open science, means to have the chance of spreading our knowledge and to publish and to have our data easy access to our data using digital and collaborative technology. To doing this, we needed the creation of an integration system. Integration system like Copernicus Service, Marine Service, and GHRSST. This is an example of an integrated system. Why? We use the same file format, in this case NESCDF, and the same protocols. Okay, NESCDF file format are open, self-describing, portable, scalable, appendable, and whatsoever. So they are fair, fundable, accessible, interoperable, and reusable, and supported by the most widespread services. This is just a list you can read by your own. Okay, is it enough to use the NESCDF format? No, we not only need a common data format, but also a common metadata standard. That is why CMM's data specification should communicate and should be as equal as possible as GHRSST Data Specification. That is an example of year and year of experiences within the SST scientists. Obviously, within the SST TAC, we adopted this specification, the GDS specification, in order to have an harmonization of what we put inside our files. So this is an example of the beginning of my history in CNR within the MyOcean project, in which every producer put inside the NetCDF the same variable, different information. And for the user, and also for ourselves, it was so difficult to use the data. So this what mean that GDS specification was and is a need for us. The pros of using it, so is the visibility for us, is the more visibility of SST TAC data that is not delivered not only through the Copernicus catalog, but also through the GHRSST catalog. We have a strict standardization, what we put inside, and also following the GDS convention, we improve harmonization among different products, and that leads to more homogeneous interfaces, and so an easier use of our data. A valid support to export GDS benefit to the world GMEMS catalog is one of the task of the technical working group that started since 2018, with the aim of widespread the benefit of GHRSST all around the CMEMS catalog. In this last year, I mean, since 2023, the delivery system in Copernicus changed by the DU dissemination unit to the marine data storage, that has the task of aiming to drive the service towards the digital twin ocean era. And this is lead us the needed to open our point of view to the new world. I mean, the cloud world of the cloud world. And this means to change technologies and also to have a new format, the ARCO format. And so what we have learned using GDS is that is a long process. It's difficult to apply correctly all the strict rule inside the GDS convention. We need a step behind, and this step behind is given us by the next GDS 3.0. Here is a quick overview of some difficulties we found out at the beginning of our history, and why we try to have the best NetCDF as we could. Especially we had problem in harmonization in the text metadata. All these problems that I have no time to list in particular, but all these problems in using GDS convention as partly solved in GDS 2.1 and GDS 2.2, but as I said before, a lot of things should be improved, and we need, as my colleague from the Australian Bureau said, we need a NetCDF checker, perhaps also an online NetCDF checker, not only a Python NetCDF checker, and easier readable guidelines to help putting in practice GDS specification. So the scheduled GDS evolution from GDS to 2.1 and, oh, this is a mistake, 2.2 to GDS3 was presented and discussed in June 2024 and lead us to the need of connect the Copernicus Technical Working Group to the GHRSST team in order to have a ARCO format and new format as close as possible. Oh, sorry. Okay. And as close as possible in order not to have a step back to the present, but a step forward, that it means to be closer than before. I mean, Copernicus and the GHRSST system. So the new challenges for the producer is to put their data into the cloud computing world, new rules, new standardization, more closer than ever. Thanks to all, and please, you found here my my email and also the technical working group email. Thanks for all, to all.
Thank you, Christina.
Okay.
So as always, just
the consolidation. Okay, I did it.
perfect. Are there any quick reactions to Christina's presentation? Otherwise, we will move on to Joanna, who will also do a continuation of a perspective from DMI. Great, so no raised hands. Again, use the Q&A function if you have more questions, and we will get to those at the end. Joanna.
Hello, from me too. My name is Joanna Karagali, and as introduced before by Erica and Pia, I'm working in the Danish Meteorological Institute. I will share my slides in just a second. I hope you can all see just about now. If not, just ping me. So, as this third presentation in the workshop, a lot of the things have already been covered nicely by Pia and the speakers Pallavi and Christina. So I will provide a brief overview of how we implement GDS at DMI for the Copernicus Marine Service, actually. So I will give you a brief overview, and Christina already did that. So the Copernicus Marine Service has a mission to provide global and regional ocean monitoring and forecasting products. It is separated in regions, regional products, and also there are some global products. And it covers the essential marine variables concerning the blue ocean on physics, the white ocean on sea ice, and the green ocean on biogeochemistry. And as mentioned earlier, the products are either based on models or on observations, satellite or in situ. So the main inputs of DMI are on the blue ocean, and they are related to temperature. Hence, this presentation also on how we implement the GDS. But it is important to note that the Copernicus Marine Service also has some formats and specifications, not on the data themselves, but on the procedures we need to follow. And Christina nicely mentioned those related to the product user manuals and the quality information documents. So the information is streamlined. So most of the things that Christina mentioned earlier hold also for the products I will present now. And also another important thing is that the Marine Service website has a very nice visualization tool where someone can actually select the product and visualize the variables of the day or of the time series that is available on the Marine Data Store. So I will also give you a brief overview of the two major thematic assembly centers that DMI participates to with products. And the first one, as introduced by Christina already, is the Sea Surface Temperature Thematic Assembly Center, or SST TAC, which as a mission has to provide state-of-the-art level 3 and level 4 products from satellite observations. And these products are available in near real time operationally, so typically in the same day or next day, and also as a multi-year reprocessed products. And obviously, it is a science and user-driven service in the sense that we always try to tailor the evolution of the SST portfolio to the user's needs and requests. And every year when we make evolutions to our products, we try to incorporate the usability of our products and what the user requests, but always also try to improve their quality, to add new relevant products and variables, to improve the temporal and spatial resolution of the products, obviously to extend the multi-year time series to cover at least the previous full year. And one of our key activities is also to contribute to the Ocean State Report, which is a report that is released by the Copernicus Marine Service annually. And just as a schematic of how the SST TAC operates, on the right-hand side, essentially, we are the partner institutes and the production units that cover regions from the Mediterranean, as Christina mentioned. The DMI is covering the Baltic Sea region. And essentially what we do is that we gather typically level 2 satellite data from producers that also follow the GDS. And we process the input data to level 3 and level 4 products, also following the GTS, like Christina mentioned, that then we aim to target various applications from the external users for scientific analysis to our own MFCs, modeling and forecasting centers, or other modeling centers for assimilation, and also obviously contribute with scientific results. And then DMI also participates with products to the CI's Thematic Assembly Center, which as a mission has to deliver near real-time and multi-year time series of satellite-derived information products that cover CIs for the Arctic and Antarctic Oceans and for the Baltic Sea. The list of portfolio products for the CI stack is more extended. It doesn't only include temperature like the SST TAC does. To the contrary, actually, CI's temperature is a smaller chunk of the product portfolio. There's a lot of information on ice drift and sea ice thickness and iceberg monitoring and sea ice concentration and all relevant information, mostly related to sea ice and its evolution. So for the sea ice stack, DMI mostly contributes with not mostly, but I am here to cover our contribution with sea surface temperature and sea ice surface temperature. We contribute also with other products, but they are not GHRSST data compliant. So as a production unit, the biggest part of our portfolio is depicted in this slide here. So for the left-hand side, you can see the products we contribute to the Sea Surface Temperature Thematic Assembly Center that have the codes available in every line. And you can look them up on the link here of the Copernicus Marine Service. And the same information that Christina showed before will pop up. So there's going to be a description of the product. There will be link to download the PUM, the QUID, and the scientific quality overview documents, and also the link to access the data. And also I list here the time for which the products are available. And we have near real-time products that start from 2016 or later, depending on the product. And we also have the multi-year time series, which for now cover about 42 years of observations. And they are all GRIST compliant. And I can show you later how these kind of multi-year products are used. And then on the right-hand side, you see an overview of our sea surface temperature and sea ice surface temperature contributions for the sea ice stack, for which we provide one near real-time product covering the Arctic. And also we provide two multi-year products, both as level 4 and level 3S. And again, these products are GRIST compliant. And here is a brief overview, a generic overview of essentially how do we handle data and our processes. And of course, this schematic changes a bit depending on if it's a near real-time product or a multi-year product, and also if it's for the Baltic or the Arctic. But essentially, the main message is that what you see on the left-hand side is our input data, which is typically level 2 and level 3 SST and or IST, depending on the area, that are GRIST compliant. And then some type of sea ice concentration information, depending on what we want it for, which region we are looking at. We are pre-processing the input data to level 3, and we create a level 3 super collated product, which gathers all our information in the grid, but has gaps because of missing data. And this is also a product delivered to Siemens. It's the level 3S version typically. And then that field goes through an optimal interpolation algorithm to provide the level 4 SST and associated uncertainty. So all our products are also available on the GRIST catalog, which was mentioned earlier. And here you see a print screen of the catalog where I have explicitly chosen DMI, so our production unit, and has a list of some of the products, at least the ones that could fit into the screen. And of course, this is very important because it's a centralized catalog where users can find information of all the GRIST products, or the products following GDS at least. And it is also very important because it allows for users to be very familiar with all the products simultaneously, because once you know how to use one, you essentially know how to use them all in terms of the naming convention that we use for the variables, the naming conventions we use for files, the file structure, and what is the understanding and the definition of the product level specifications. And I mean level 2, level 3, level 4. Now I will move on to some of the things we also use our multi-year products for. And as to remind you, they are long reprocessed multi-year data sets that cover at least 40 years. And we provide those both for the Baltic and for the Arctic within the SST tag, and I will show you later on for the sea ice stack. And one of the key things we use them for is to provide ocean monitoring indicators, and these are also provided in the Copernicus Marine Service. So what you see on the left-hand side is an example of the annual mean sea surface temperature anomaly for the North Sea and the Baltic Sea for 2023, so for last year. And the anomalies are relative to the 1991 to 2020 climatology. And on the right-hand side, you see the monthly mean sea surface temperature anomaly for the Baltic Sea only, where the annual trend throughout the period of data availability is also calculated. And these ocean monitoring indicators are also available on the Copernicus Marine Service. And similarly, for the sea ice stack, we provide exactly the same type of indicator over our Arctic products. And you can see on the left-hand side, the annual mean surface temperature anomaly in the Arctic, again for 2023, and the monthly mean sea surface temperature anomaly time series on the right-hand side, where the trend is also included. So overall, this is my presentation, and thank you very much for attending. And any questions now or later?
Thanks, Joanna. Are there any questions or a question in the audience that we could answer quickly now? Otherwise, again, use the Q&A function there. Perfect. So our last speaker, so right now we've listened to 3 different perspectives of data producers implementing the GDS, but now we're going to move over to Neeraj Agarwal from ISRO, from the Indian Space Research Organization, who will sort of give a perspective of an organization just starting this preliminary steps towards implementing the GDS. So you have the floor now, Neeraj.
Hello, good morning, good afternoon, good evening. I'm Pradeep Thapliyal, and I'm sitting here with my colleagues Rishi and Neeraj. So I'm going to talk about this SST product from recently launched INSAT 3DS imager. As you know that we had INSAT 3D series, we had 3 satellites. INSAT 3D was launched in 2013. 3DR was launched in 2016, and then this year in February we launched INSAT 3DS. 3D and 3DR, we had a small problem with the black body calibration as well as midnight sun intrusion and in the imager observations. So SST observations are not, there were a little large uncertainty, particularly during night time. But inside 3DS, those problems have been mitigated with the instrument design. And this time we are very confident that this product will qualify. So quality is very, very good. And this is what I'm going to talk in this presentation. And because of those large uncertainties, we could not make a GDS format data for INSAT 3D and 3DR. But now, because we have seen the quality and consistency of the data from INSAT 3DS, so we will be going ahead with creating a GDS format data from this satellite. So this is what INSAT 3D is. This was launched in 17 February, and it is at 82 degree east, replacing INSAT 3D at that location. And this algorithm which we have is a standard non-linear SST algorithm. And this SST equation is shown here. And we are only utilizing right now thermal split window thermal channels TIR1 and TIR2. And in future we would like to include an MIR channel also, because in 3D 3DR we were facing a little problem, but now we are sure that we will be able to include that also as well for night time. But so far satellite is not made operational. I am just showing some of the initial results from this sensor. So you can see the sensor sample SST product. This you can see 6 UTC on which the date is 9th September, and recent data. And this is at one time, and the right panel you can see that this is daily composite SST, and the quality of data is very, very good. I will show in next. This slide shows for starting from 1st August and till now, 30th September. So 2 months of data is shown here, and you can see that the green line is standard deviation, and this orange line is actually the RMSE. So the values are quite consistent throughout the period. There is very little deviation during day-night as well. And these you can see here, these are the number of data points, this one shown here. And this one is, this blue line is a bias. So bias also is very small. It's around 0.3, 0.4. And that also is because this imager observations are surface skin temperature, whereas this in situ observations are bulk. So that is the bulk skin difference. And you can see here the scatter plot for these 2 months, and you can see bias is minus 0.38, RMSE is 0.81K, as well as the standard deviation is 0.7. So this has improved quite a lot from INSAT 3D and 3DR, where our standard deviation was of the order of 0.85, 0.9. So that improvement is evident here, and along with the consistency throughout the period, including day-night variations. So with this statistics, we are confident that we will be able to qualify this data for GHRSST GDS format data. So now, right now, we will be making this operational within the next month.
Hi, Pradeep. We seem to have lost your sound.
This data format. And for that, actually, we would like to understand, once we want to go for GDS format, what are the basic requirement, how to compute SSES, that is sensor-specific error statistics, because we did not find any standard document on that yet. So we will need some help, some support in that direction. And also, as I do not know what is the standard procedure, whether we have to prepare an ATBD and present it in science team, or directly it will be taken as approved from our center, our ISRO. Then the next step will be, because right now there will be data gaps corresponding to clouds. So in future, we will be merging this SST product with the other platform data to make a gap-free SST products. So this is what is our presentation here, and we would like to get comments from other experts sitting here, whether we can go ahead and what are the minimum requirement to qualify for GHRSST. So I'm open for a question now.
Perfect. Thank you so much, Pradeep, and the whole team. I wonder if any of our presenters today have any sort of reactions or advice for the team in ISRO. Otherwise, I will facilitate these questions. Also, if you share me your presentation as well, we can also send this out to some of the science team members, and also maybe Jeff, because he's quite involved with the GDS. So yeah, it'd be great. And then we can also sort of, get those answers out to you.
Okay, thank you.
Great. And are there any other questions in the audience here? I know there was a question that was directed to Pallavi asking about how to decide which SST product to use. And also if you could elaborate a bit more on the decision tree process, which I know that Pallavi, you have answered in the text, in the chat here. But I don't know if you want to elaborate more on the decision tree process there.
So for the SST product to use, there is plenty information available. So basically, you first ask what depth you want a product at. There are products at different levels. So with the satellite, you get skin level and then also the foundation level. Whether you want infrared sensor or micro juggles. And then the resolution of the product. So as mentioned in the all the presentation, there are hundreds of different products, and it is challenging to decide which one to use. So I have shared one chapter in that answer that Helen Beck from the Bureau wrote on how to choose SST. And yeah, you can always contact to SST producers to get some advice. And that is one thing. The other thing on hierarchy. So again, to choose the satellite of your preference. It again depends the resolution of the satellite, whether it is the polar orbiter or geostationary satellite, your interest, region of interest, to give the preference of the satellite SST. So for Australia, our L4 products, we give VIII a polar orbiter, and it is a very accurate sensor. So we give a preference to VIII, followed by AVHRR, and then microwave, and then in situ SST. So yeah, it depends on your application and your region of interest, how to give the preference to the satellite sensors. That's from me.
Thank you, Pallavi. I also put in, yeah.
Yeah, and I was going back to Pradeep's presentation about the SES bias model. So yeah, there is no standardized method for calculating SES, and every producer develop their own method. At the Bureau, we have two different methods, one for the polar orbiter and other for geostationary satellites. So yeah, at our end, we use some of the empirical information to develop that bias model. And yeah, we use in situ SST. So yeah, you can develop your own method and give the uncertainty of the observations that you are giving. Thank you, Erika. I think that's from me. Unless there are further questions.
Thanks for addressing the question from the team at ISRO there. We have 3 more minutes left on our time here, but of course we can stay in contact with each other. And I'm also adding the email for the GHRSST project office in case you need to get in contact with the right people. We can also help you, direct you here. So that's in the chat. I also put in the guide that Pallavi was just mentioning, that Helen Biggs from the Bureau of Meteorology has helped to produce. So that's in the chat there, and that's also where you can find how to choose an SST product there. But are there any other questions in the audience? All right, so what I'm going to do now is just share a quick post-presentation Slido to see if we have potentially learned anything from our presentations today. So I'll also put the link in the chat here. So if you go to that and find the link or scan the QR code, it'd be great to understand our first question here. So how much do you know about the GHRSST data specifications now? So after we had our presentation from Pia, who presented what it is, the benefits of it, why you should adopt it, where to find it, and so forth. And then we had our 4 perspectives. So from people who are implementing the GDS, going to also ISRO, who is starting to implement the GDS. So in our last pre-presentation Slido, we had the majority of people not knowing anything about it. So now it's good to see that we have a little bit of progress here. And then if we can just go to our last little poll here. Do you have any key takeaways from today? Anything that you have learned, or yeah, you can pop your short points in there. And thank you, Pia, for also adding this. I will paste it into the chat for everyone. So some information on the SSES common principles can be found there in the link. Very interesting data sources, data fragmentation, specs, technical, time, details. GDS is important. Great. So without, thank you so much everyone for joining, and thank you mostly to our presenters here, and also Pallavi, because I know that it's quite late for you in Australia, but thank you again for taking the time to build these great presentations. Yeah, so just keep in touch. We have our, like I said, I put in the GRIST project office email here, and you can also just go to the website, the GRIST website, to find any resources that you may have. But other than that, thanks again, and see you around.